After the previous video where we drew out some specific titration curves for a strong acid and strong base, weak acid and strong base, and we looked at the pHs in the different regions and what's present and why the pHs are what they are, I thought it might be good to just draw a little cleaner version of those titration location calculation summaries. So I'm going to very quickly sketch out these titration curves, and we'll throw on there just some generic colors for our purposes here. We've got our strong acid with strong base. And that's not the world's greatest picture, but it'll do. And then we've got our weak acid with strong base, which looks like that. Now, those aren't the greatest pictures, but that's fine because we don't need them to be. I'm going to draw in this line right here. This would be the volume at the equivalence point. I'm going to draw in this line right here. That would be our volume at the equivalence point. On this graph also we have a very important point. We'll just call that our equivalence point, and that is halfway to the equivalence point. All right. So at this point, half VE over 2 we'll call it, that's where our pH equals our pKa. All right. So quick summary on that, pH equals pKa there, and if we need to calculate here, we have excess H plus. So this entire region we're going to calculate as the negative log concentration of H plus. All right. At this point right here, you don't have to calculate anything. The pH is 7. On this one right here, we have exceeded the equivalence point with our base, and so everything over here, calculation is going to be based on concentration OH minus, excess OH minus. And so you can just rearrange your pH equation and say the pH is going to be 14 plus the log concentration of OH minus. And then we jump over to here where we have a few things that are different, one of which is this point right here. Since you're starting out with your weak acid, to get that calculation, you're going to have to do ice. Okay? And also, when you get to this point right here, you're going to have to do ice. Everywhere in between those 2 points, we have a buffer region, and so it's very convenient for us to do the Henderson-Hasselbalch equation. We have a mixture of our weak acid with its conjugate, which means that we have the Henderson-Hasselbalch equation. And if you forgot that, pH is pKa plus the log, your amount of A minus over HA. All right? That is the Henderson-Hasselbalch. After this ice point right here, we have the same scenario we did there, excess OH minus, and so we can calculate our pH based on that. All right, so you have, I guess, 1, 2, 3, 4, 5 different ways to do things, and then you've got ice there in reverse. All these things I show in a couple videos later, but this is a pretty good summary of how you calculate what where.